Let me just quickly showcase the tool. Open up the asset browser and go into the tool section. I drag this tool into the scene, and you can see it also includes a curve profile. That is not necessary, you can use whatever you want. I create a few collections, the curves collections, those are the base curves, and I'm also gonna create a collection for the curve profiles. Alright, so let me demonstrate this tool. On the right hand side in the geometry panel you can adjust the radius, the resolution of the profile, and the resolution of the length of the curve. The cap scale will determine the scale of the cap, of course. You can see it right here, it gets thicker or flatter. If we rotate around a bit, you can see that we can also introduce a taper, and we can reset that taper because it can interfere with our trim path. Like I said, the trim path, we can use that. We can enable a custom curve or a custom curve profile. Enable it right here with the checkbox. And let's introduce a new curve profile, say a star. That's fine. We have to switch this in the curve panel to be a 3D instead of a 2D curve. And that's exactly what we want. Now we can go back to the geometry nodes and set the custom curve profile to be a star. The only thing I'm a little bit disappointed by is that we couldn't visualize the curve profile on the right hand side in the modifier stack. We have to go inside of geometry nodes and look up the RGB curves. That is the taper profile. And if you play with the curve, you can see that you can shape the curve taper. So let me quickly demonstrate how you can do this from scratch. We're gonna add a new curve, a Bezier curve. And in edit mode, I like to scale that up just so it's a bit more visible. It doesn't matter really. Rotate it in the viewport. You can shape it however you want. We're gonna go to the curve tools. I'm duplicating that and I'm taking the number on the end to make it a unique version. Then changing out the base curve to our newly created curve, and you can start shaping it in edit mode. You have to do this from the original curve. You can't use the curve tool because it's actually a mesh. If you just want the tool, go to Gumroad and download it from there. Download the curves tool at a pay what you want basis. All contributions help the channel make more content like this. I believe that knowing how this tool was set up will help you use it and even adjust it so that you can use the tool however you see fit. Alright, let's set it up from scratch. In a new file, we're going to add a curve. Start with a Bezier curve and go into edit mode, shape it however you like. I'm going to rotate it on the x-axis so it's facing a bit more up. Then you can place it in a new collection. It's not necessary, but I usually like to do that for my base curves. Create a new collection for the tools as well and add a new plane to that collection. That is going to be our tool. Okay, one more collection is the curve profiles. I like to keep these separated just for overview, I guess. And head over to the geometry tab. In here we can see that we have now created a new geometry node setup for our plane. I'm gonna pin it so that we can easily drag this curve from the right hand side after I renamed it test curve. Drag it into our scene, and I can disconnect this line between the in and output and rather use the object info and the geometry socket to go in the output. So grab a empty socket of your group input node and connect it up to the object field, and that will display our field in our modifier stack. If you want to later reuse this, it's always good to start naming things and do that from the start because it's easier than going back and seeing whatever the hell it is you have done. So I'm going to rename this object. Sorry, I deleted the geometry. I didn't need to do that. I renamed this to base curve. And you can even add a description if it's going to be for someone else, or if you just want to make sure you use it the way you have intended it to be used. All right, so I'm gonna reshape this. You can see that it's actually working. I like to work from relative just to always know that the curve is at the exact point the base curve is in our scene as well. We're gonna start simple and we're gonna add some functionality. For example, to set the resolution, I'm gonna use a resample curve node and set this to count, and basically the count will determine how many points there are on the curve. Use this count socket as well in our group input node. Again, I like to rename it, and probably it's going to be something like resolution. You can set a default value here. You can set a minimum value. I like to set it to 2 because a curve with 1 point is just useless. So basically stick to 2. And with that, we're going to head on and we're going to see how we can make our curve into a mesh. We use the curve to mesh node. And so let me, for visibility, create a frame around this so we can separate the sections of this group node. That is going to be expanding a lot. The curve to mesh node doesn't do anything. We're going to add a profile. So in this case, we're going to drag from the curve, the profile curve. The curve circle is automatically attached. I also reframe this because it's now just a circle, but we're going to expand on this as well and name that frame as curve profile. Some basic functionality that every curve should have is the ability to grow along the path. And we call it a trim path or a trim curve. Insert that node into the scene. And we're going to insert the trim curve node into our node group. I'm going to place it in between the object info, which is our curve, and our resample curve. And the start and end value will do exactly what we intended to do. It will grow and shrink from either the start point or the end point. Connect those sockets up to the empty slots in our group input, and that will display the start and end value on the right hand side in our modifier stack. Today we're going to use two methods to create our round corners or our caps for the curves. I'm going to continue using the latter because it's more useful for creating a custom curve profile later on, but just so you know, there's another method as well. How to create a hemisphere, as it is called. We're going to use a UV sphere, import that into our scene, and connect it up to the group output. You can play with your segments and your rings, and usually it's good to have your rings be double of what the segments to be double of what the rings are. Basically, a hemisphere is half of a sphere, so we're going to delete some geometry. Now with the delete geometry node, it deletes everything, so we need to make a selection. This selection is going to be based on the position of the sphere. If we're going to compare this position to set value, you can see that some parts of the mesh will disappear and some parts of the mesh will appear. Of course, this is another selection that we need. We need to separate our position in the X, Y, and Z. Like I said before, I like to divide the amount of sections by 2. So we're going to add a math node and do exactly that. We're multiplying it by 0.5. And then because we're dealing with odd and even numbers, we're going to snap it to 2s. So again, a math node, set it to snap, set the value to 2 and place it in between there. Okay, to make this a bit more neater, I'm going to select everything and then group it. You can rename this group to, say, hemisphere. For the second time, we're going to create this a bit more manually. We're going to build up the cap a bit more manually because we want to be able to use a custom curve profile. This will make sense in just a bit. Okay, back in our original scene, I have duplicated the curve profile because we're going to need it on 2 places. I'm going to use a viewer node, so just not to be distracted by the curve itself. Now with everything in place, we're going to look up a new node. We're going to search for the curve to mesh. There you go. Now our curve circle is a mesh circle. We can see it right here. Still, the functionality is the same. We can adjust the radius and the resolution. However, with it being a mesh, we can now use functionality like extrudes. So we're going to do exactly that. We're going to introduce an extrude mesh node. And you can play with the offset scale however you see fit. I'm going to use 0.7. For the selection, we're going to use a combine XYZ, and in this instance, we're only going to use the Z value. So set the other two to 0 and the Z value to 1. Then duplicate the extrude node, place it here. We can use the offset scale again, just doing something weird. That is because we need to use our selection and our offset because we only want to go up. So we're going to use the same offset in the Z direction, and it's still a bit glitchy, so we're going to use the top selection right here. So you see it's now working, and if we combine those two, it's working exactly as we want it. This offset scale I'm going to set to 1.5, and after that I'm going to introduce a scale elements node. This scales, like it says, the cylinder we now have created. And now if I introduce the top selection again, you can see if I scale it, oh sorry, it's not working, and that's because we have to set it to edges. Now when we scale it, you can see that the edges now edges now diverge or go the other way around. We're going to repeat this process again, introduce a new extrude node, and this way we're going to build up the cap. So we use an extrude node, set it to 1.1, grab the scale node, duplicate it and place it behind this extrude node. You can adjust the scale value here again, 0.6 in this instance. And also keep your selection going. Like every time it needs to be only the top selected. I guess this is the last extrude node. We're going to use again the same offset. And we're going to use the same selection as well. The top selection of the previous extrusion. And one more time in scale node. This scale node is going to be the one that closes everything. After that, introduce a merge by distance. This will merge every vertex that is in a certain distance of each other and merge those to a single point. If you really want to be precise about it, you can now go and import a UV sphere, join those meshes together, the one you build up and the UV sphere, and you can see I want the point to be facing downwards, so I'm gonna go back and say change the Z value. I'm going to use also a bit of a math node here. I want the range to be a bit tighter. So I'm going to divide that by minus 100, minus so that it's flipped, and 100 so that the value is now a bit more precise. This way we don't have to use tremendous amount of numbers. We can just have the range a bit more, and then adjust the other value that is now 0.5 to be whatever it is you need to match up with the UV sphere. I have grouped this into a group node and I'm calling this build up custom profile cap, just to be very descriptive. As you can see, we can, for the cap, still use the curve circle and say the resolution is whatever number using the curve circle. Okay, we have now created our cap, our second one actually, and I want to do one more thing. I want to go back into the group node because I want to expose this value so that we can influence that outside of the group. Rename this to say cap scale or cap whatever you want. Okay, and now we have that value exposed outside of that group. You don't have to go inside the group. Every time you want to tweak it, you can do it from out of here. One way or the other, we now have our curve cap, or the rounded corners we're looking for. The only thing is that we need to be able to align it to the curve. We're going to see how we can do that in the next section. All right, so I'm going to make some room here. Then down below where we have our cap curve, we can go ahead and create curve to points node. Place it in between the resample curve and our viewer node. And you can see that we have an array of points that follow our curve. Yeah, to be exact, there are 10. Of course, our curve only has 2 endpoints, so we're going to set the count to be 2. We're going to use an instances on point node. Our cap is going to be the instance, and you can see that they are placed on the right point, but they are rotated a bit off. Or to be precise, they're not rotated at all. If I use the rotation here, you can see that I can rotate them, but they rotate simultaneously, and we need to be able to separate those two so we can align them both. To do this, we're going to need a rotate Euler node and connect it up to the rotation of our instances on point node. Set it to axis angle and use the normal and set that to the axis. And use the rotation value and set that into the rotation value. You see that they are aligned, but the endpoint is flipped. But the endpoint should be rotated 180 degrees. And for that, we're going to use the angle. We're going to drag from the angle socket right here and use the index. This only makes a slight difference, but we're not entirely there yet. I'm going to disconnect it because I need a math node in between here and set that to multiply. Connect this up to the angle again, still not rotated correctly. We're going to use pi, and now it is rotated 180 degrees. From this front angle it looks still a bit off, but you can see if I rotate around it, it is actually aligned perfectly because the curve is going a bit more, has a slight bend in it as well. So it is perfectly aligned. We're using pi because that's in radians half a circle. Okay, this is what we want. I also framed this and called it instancing, align, and flip. The flip part will make sense a little bit later, but we'll get to that. Just to recap what we did, we have a curve and that has 2 points, 1 and 2, the endpoints. And those are both the indices as well. We're going to use those indices and multiply them by pi. So it's 1 times pi and it's 2 times pi. This works because we only have 2 points. That's why we use the curve to points node. If we say, for example, we're using 3 points, you can see that there is now added 1 in the middle, which becomes the second point. Our third point will flip back to the original position. Now when we use 4, it's back to the right orientation. Only we have now introduced 2 extra caps in the middle of the curve between those 2 end caps. That's not what we want, so we're going to stick to 2. So I understand if you think this is a bit complicated. There's also a node you can use that is a math node that is set to radians and use the degree as 180 and connect it up to the socket we used before that set pi, the value that set pi. This is basically the same. We now have our caps aligned and we can basically go ahead and join the 2 together. So introduce a join geometry node and join the curve mesh and the curve caps together. This will join them as in they're in the same mesh space, if that is even a term, but they will not be merged. So we're going to use a merge by distance again and place it after the join geometry nodes. There's one little bit of a inconvenient issue here. We're gonna fix that also. You can see that the curve and the curve caps are scaled separately. Okay, so we're gonna use the radius here and create a group input node. This connects it to a new socket. Perfect. We're gonna unfold that by using Ctrl H, I believe, or Shift H. And also connect the resolution here to the group input node. I just drag one of the inputs above the other. First I'm gonna collapse the group input node, and then I'm going to duplicate it and place it on top here. Connect those up as well. And now on the outside of our geometry node setup, we can increase the radius and the resolution. You see there is a slight issue there, creates a gap in the middle. I just have to increase the merge by distance. And you can merge this to whatever you want because we only use the selection, so it's only gonna merge the outer or the last group of vertices, and that's gonna be merged into one point. So now it's time to test if they are indeed perfectly aligned. We're going to open up our base curve collection, and with that base curve collection open, we can go in edit mode and you can see that it indeed follows our curve path. Perfect. I'm really getting into it, and why would we stop here? With the caps aligned to the actual curve and everything working together, we can go ahead and introduce a new custom curve profile. In the viewport, I'm going to add a curve circle. We're going to modify this curve circle. I'm going to create a heart shape. Why not? If you're done creating your custom curve profile, we can import it into our geometry node setup. Of course, we now use 2 separate curve profiles. So we're gonna introduce that on the bottom as well. Do the same thing, use the object info node with the curve and feed it right into this group node that builds up the cap. Perfect. This section right here is not aligning, but we're gonna fix that later. We're first gonna focus on a few other things. I'm going to disconnect the cap so we can just work on the profile of the curve. I'm using a resample curve node. This is going to allow us to set the resolution of our custom curve profile. Using a transform geometry node, we can set the radius by adjusting the scale. Now we can group this together and expose both settings outside of the group. So we're going to expose the scale and we're going to expose the count. And maybe flip those in order. Then outside of our group, we can go ahead and connect it up to the previous group inputs that say resolution and radius. And if we copy this frame over down below here, we need to, of course, delete those, grab the frame, place it here, and connect it up to the build up custom curve, connect that up to the instances on point node. And now we have a cap that uses our custom curve profile. This is nice, but we need to be able to switch between the 2. And what better node to use for that is the switch node. Okay, the switch node switches between 2 pieces of geometry. So we're going to switch between our curve circle and we're going to switch between our custom curve profile. This checkbox is the thing that allows us to switch between those. So we're going to expose that also in our group input node. We have to unfold the group input and connect the switch up to an empty socket. Then rename this to enable custom profile. And again, we're going to use this custom curve profile down here for our caps as well. Now, if you remember, we are still left with a minor issue. It's when we switch to a custom curve profile, the alignment of the end section is flipped. We're going to fix that in the next section. Insert a scale instances node. Use the scale value right here and drag it out of this frame. Doesn't have to be, but I like it to be outside. And because we're going to create a smaller section as well, and use the index. Then we're going to use a switch and set it to integer right here. Connect the index, which is an integer, to the switch. Index number 1 is here on the left hand side. Index number 2 is on the right hand side. So the switch will tell that the index 1 is a value of 1. The index 2 is a value of -1. This is actually needed because we need to flip one of those endpoints. Use a combine XYZ and use the output of the switch node in the Y value. Connect that up to the scale of the scale instances node, and now they both disappear. This is because we have set the values of this vector of the X and the Y to 0. So if we change that back to 1, you can see that they appear again. Now both caps are aligned perfectly and flipped in the right direction. You can see, however, that indicated by this line, the curve and the cap are not connected. That is because we need to realize those instances. However, this introduced another problem which caused me a lot of headache. You see the endpoint now is flipped in its normal. You can see that one or the other turns red or blue. Okay. We need to capture the state of this cap before it is realized. So we're going to use a capture attribute node. We're saying it is not a float. We're going to switch that, or it's going to be a boolean. We're going to use the selection we have created earlier to flip it and use a compare node and set that to equal. Change this from element wise to dot product and set these values to 1. Then we're going to connect it up to our boolean socket right here. Our flip faces need to be enabled again and set that to the selection. That didn't do what I thought it would do. Let's see what is wrong. Let's go down here, and the C value, we can set it to 1 as well. Still not what we want, so we're going to go back, see what we have done in the capture attribute node, and there it is. We need to change from point to instance instead. We can see that it is flipped entirely, so we're going to introduce on the end again a flip faces node. It is now blue, which means all the faces are pointing outwards. Perfect. Yeah, I really struggled with that too, but hey, we made it. Also, we're not done yet. We're gonna introduce some new features like a taper. Let's see how we can do that. We have seen before that it doesn't necessarily mean that the cap and the curve itself work together automatically. So we're gonna disconnect the cap for now. On the section after the prepare path, I made some extra room because we're gonna introduce some nodes here to control our taper. Start with a set radius node. This will drastically decrease the radius because it is set to a low value. I changed this back to 1, which is the original value. We're going to use the radius value here and create a new node. And that is our spline parameter node. And specifically, we're going to use the factor, which creates a factor from 0 all the way up to 1. Let's create a node that will allow us to control this. Introduce a RGB curve node. Now drag the point here at the start to the top. But then when we introduce a new point in the middle and drag this down, you can see that it is indeed creating a custom taper. Alright, like I already predicted, when we introduce our caps back, you can see that it isn't working. What we need to do is we want to capture our radius. So search for a capture attribute node, place it in between here. There you go. Drag it out and search for radius. No, not the group input radius, the radius. Okay. Then drag the attribute out. I reroute it so we can go a bit further down the line. Call this captured attribute, or captured radius, sorry, so that we can always see what it is that we have created or what it is that we are inputting into our next section of this node tree. Again, a scale instances node. If we use this captured radius and plug it into the scale, you can see that it works. Of course, the transition of the curve depends on how you have sculpted your curve, but yeah. When I was playing around with the curve and the taper, I quickly found out that it was super helpful if I could easily reset the taper, because I didn't want to go back in and reset it and place all the points at 1. I just wanted a quick way to do that. So I introduced a new curve, an RGB curve, and now I'm going to use this down arrow right here, drop down, and reset the curve. Now place this point here all the way to the top. Then mix those two curves together. It introduces a mix node. It's set to add. We don't want that. It is a mix value that we need. And if we switch the factor from 0 to 1 or 1 to 0, we can see that we are switching between a taper or a flat or a non-tapered curve. We have included most of the functionality that we wanted. However, there are a few more things that I want to do. First of all, we want to tie in and clean up everything so that it is exposed properly outside of the node group. Then I'm going to introduce a few more things, tiny features that I think are useful as well. First, I forgot to expose this cap scale, rename it accordingly. And then on the end of the node tree, we're going to create some new nodes. We have our flip faces node. And after that, I'm going to create a subdivision surface node. So with this node, we can set the material, choose our material in the drop down and preview it right here. You can see a nice red curve. Cool. Grab this selection of the flip faces and create a new group input. Unfold that and also use the level of the subdivision surface and the field where we choose our material. Then last but not least, I want to expose, because I forgot this, our custom curve profile, the field where we can choose our custom curve profile. Now it is a matter of reorganizing the node inputs as you see fit. I just chose an order that made sense to me, but feel free to do whatever you want. Now that you have created a curve tool for yourself, it is time to create an asset out of this so you can easily reuse it later. Alright, go into the outliner, right click and say Mark as Asset. Now we're going to head over to our section down here, our geometry section, and we're going to switch this. I usually switch using Shift and F1. There you have it. Go to unassigned because our curve tool is unassigned. And if you press the end panel, you can choose a thumbnail if you like. Then grab your curve tool and drag it to a category that you have created. You need to save this file on the location where your asset libraries are saved. For me, I named them asset pack MVArts, located at my disk, blah, 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 blah. And of course, this is going to be wherever you want to have your libraries located. So now if we open up a new file, go up to the top, File, New, and say General. I'm going to create some space for an asset browser, and again press Shift F1. There it is, our curve tool is located right there. I hope you have enjoyed this, I hope you've learned something, and you're going to use the tool for a lot of awesome things. As always, stay creative, I'll see you next time. Ciao.